welcome to an ELA Training Services Maths video. Today we're looking at scale. So what do we mean by scale? We don't mean kitchen scales or bathroom scales. This isn't any cooking session that's going on today. We're not bothered about how much things weigh. What we're bothered about is a scale where we've taken a large area and reduced it to a small, manageable concept. Now this may be something you see in kilometres, it may be something you see in miles, it may be something you see in metres to centimetres. And where could we find scales? Maps. We find scales on maps, and we find them on the maps that we get on our phones and on the internet, as well as maps in paper form. We also find scales on scale drawings. This might be for wildlife pictures, it might be for a scale drawing of a tree, for blueprints of a house, and you'll see those on websites where you're looking for houses to rent or to buy, where they show you a house footprint, and the floor plan will have each room to a scale so that you're aware of the size of the room, the house, the whole building. And lastly, things like vehicle design. If you're a mechanic, you might be aware of these already, or it might be that you've never come across scales in any way, shape or form before, and that's fine. By the end of this session, you should be more comfortable with what a scale is and how to use a scale. So, a scale is where we're able to draw a large object on a smaller scale, and the scale has to remain consistent throughout the drawing. It's no good having one scale for the bathroom of a floor plan and a different scale for a garden of a floor plan. It makes it too messy and confusing. We all need to be on the same page. You also have to write the scale on your drawing, and they're expressed as ratios. So we're aware of what a ratio looks like, but this time we've factored in measurement. So of 1 centimetre to 100 centimetres means that for every centimetre on your drawing, the real life measurement will be 100 centimetres. So let's look at this in a real example. Here, the TV is 4 centimetres wide and 2 centimetres high. We know that the scale is 1 centimetre to 25 centimetres. So, what's the actual width and height of the TV in real life? Well, first things first, 4 centimetres, to make it real life centimetres, we have to times it by 25. So 4 times 25 is 100, and 2 times 25 for the height is 50. Now it's important in your exams that if you work it out as a maths sum, you must put the answer with the scale on, so that the examiner is aware that you know what you've measured or worked out to be. So the actual size of the TV is 100 centimetres wide and 50 centimetres high. Let's try this one. Now this time it's the same width, it's still 4 centimetres wide, so we can bypass because the scale is the same. So we remember from previously that that means 4 times 25 is 100 centimetres. So we can bypass that, that's quick. And the next thing we're going to do is 2.5 for the height. So 2.5 times 25 is what? Now for those of us that have a calculator, we can just pop that in, easy peasy. But for those of you that are doing it with mental maths, let's break it down. 2 whole 25s is the first thing we need to add together. The next thing we want is half of a 25, and half of 25 is 12.5. Then we're going to add these three things together. Decimal column, 5 plus 2 zeros is 5, put the decimal back. 5 plus 5 plus 2 is 12, so the 2 goes under here and the 1 gets carried across. 2 plus 2 plus 1 plus 1 is 6. So you have a width of 100 centimetres and a height of 62.5 centimetres. You may be asked to do it backwards. You may be given the scale, 1 centimetre to 9 metres, and the final real life sized triangle. And then what they want you to do is draw a scale version of this triangle. So we need to do it backwards. Now we've been given here 27 metres. So we know that for every 9 metres, it's 1 centimetre of drawing. So we need to divide 27 by 9, like this. Now 27 divided by 9 is, and for those of us that don't know our 9 times table, we're just going to write it out. 9 plus 9 is 18, plus 9 is 27, plus 9 is 36, I've got a comma between them, plus 9 is 45. So, to touch 27 we have 1, 2, 3, so 9 into 27 goes 3 times. So here we are, 3 centimetres. The next thing we're going to do is 36 down here. Well, we already know that that's 4 because we worked it out. So that means it should be 4 centimetres here. And lastly, 45 metres becomes, that's right, 5 centimetres. So all we're doing is dividing this value by this value to get this value, or in that case, this value. Other maths examples in exams that you might get are where you're given a map, and it might be that this map is literally 2 bullet points, one to the other, or it might be that there's extra things on the drawing, buildings, rivers, fences, etc., etc. Now, what we're going to do is look at the scale, 1 centimetre to 200 metres, and the distance of the map. Now, sometimes you're given this, as we are today, and sometimes you need a ruler to work it out, and it's very important that you go from the centre of the point to the centre of the point. Now, we need to do 3.9 times by 200. Now, that feels like a very daunting question. So let's make it easy for ourselves. For now, we're just going to ignore these zeros. And we're going to do 3.9 times 2. So 9 twice is 18. Twice is 6 plus the 1 is 7. Now we need to put the decimal point back. See? So put the decimal point back where it was. Now, because these 2 zeros we have to remember, what it would like us to do is move it back 1, 2 places. So we have to fill the 0 in the gap and put the dot there to give us 780 metres. For more information and more help and more worksheets, always contact your tutor. See you next time.